Hi everyone, welcome to Differential Calculus. Today we explore a special topic in parametric equations. Number one, parametric equations. Definition: if x and y are defined as functions in terms of a parameter t, so that x equal f of t and y equal g of t, then these functions are called parametric equations. Each value of t determines a point x, y. As t varies, the point x, y trace out a parametric curve C. Let's take a look at a few examples. Sketch the following curves. In A, we have x equal t squared minus 3t, y equal t minus 1, and 0 less than equal t less than equal 4. So we have a restricted range for t. Now to do the sketch, we need t, x, y, and the point x, y. So because t go from 0 to 4, we let t go to 0. 1, 2, 3, 4. When t equal to 0, do the substitution. We get 0 squared minus 3 times 0, which is 0. 0 minus 1, negative 1. The point is 0, negative 1. And similarly, sub t in for the equation x and y. When t equal 1, we have negative 2, 0. The point negative 2, 0. When t equal 2, we have negative 2, 1. And the point is negative 2, 1. When t equal 3, we have 0, 2. The point is 0, 2. When t equal 4, we have 4, 3. Point 4, 3. The first point is called the initial point or the starting point. And the last point is called the terminal point. Let's do a sketch here. Okay, so when t equal to 0, we have the point x equals 0, y equals negative 1. And when t equals 1, negative 2, 0. When t equals 2, negative 2, 1. When t equals 3, 0, 2. And when t equals 4, 4, and 3. Okay. So if we connect the point, it does trace out a parabola. And because we have an initial point and a terminal point, we need to draw the arrow to represent the path of the curve. Ah, very nice. Wow. Let's do another one. B. We have x equals sine of t, y equals cosine t, and t is between 0 and pi. So do the same thing. T, x, y, the point x, y. Now let's take t as 0. Pi over 4, pi over 2, and pi. So we see what is going on here. Okay, so sine of 0 is 0, cosine of 0 is 1, 0.01. Sine of pi over 4 is root 2 of 2. Cosine of pi over 4 is root 2 over 2. Root 2 of 2, root 2 of 2. Sine of pi over 2 is 1, cosine pi over 2 is 0. 1, 0. And sine of pi is 0. Cosine of pi is -1. 0, -1. All right. Let's take a look. Okay. 0, 1. So we begin from here. And then the next point is the root 2 of 2, root 2 over 2. Well, root 2 of 2, root 2 of 2 is somewhere right here. Next is 1, 0. And then 0, -1. So it looks like we are traveling in a semicircle path. Very cool. It is not a function. Notice that it's not a function because it failed the vertical line test. So we use parametric equation to model equation or the path that an object travel. Next step is, well, let's take a look at the derivative of parametric equation. Let x equal ft and y equal gt be differentiable functions and assume y is a differentiable function of x. Then the derivative with respect to t of y is dy over dx multiplied to dx over dt by the chain rule. And also the derivative with respect to t of dy over dx is derivative with respect to x of dy over dx multiplied by dx over dt. Same thing by the chain rule. From here, we see that dy over dx is d over dt of y divided by d over dt of x. And in this case, d derivative with respect to x of dy over dx, that is d square y over dx square, or the second derivative is d over dt derivative with respect to t of dy over dx over derivative with respect to t of x. If ft and gt, they are the position of a particle at time t, then the first derivative is the velocity. And the second derivative is acceleration. Example, let the position of an object at time t be x equal t squared minus 3t, y equal t minus 1. Find the velocity and acceleration of the object at time t. Velocity is y prime, which is derivative with respect to t of y divided by derivative with respect to t of x, and that would be 1 over 2t minus 3. Acceleration is y prime prime. According to the formula, that we are the derivative with respect to t of the first derivative over derivative with respect to t of x. So it would be derivative with respect to t of 2t minus 3 to the negative 1, derivative with respect to t, x is t squared minus 3t. Here we use the chain rule for the derivative with respect to t of 2t minus 3 to negative 1, of negative 1, 2t minus 3 to the negative 2, multiplied by 2 in the denominator, 2t minus 3. And let's simplify this, make it look a little nicer. So we have a negative 2 over 2t minus 3 square multiplied to the flip with second fraction. So 1 over 2t minus 3. Well, and that gives us negative 2 over 2t minus 3 to the power 3. Thank you for watching. I hope you found the content useful. Please like, subscribe, help the channel grow. I'll see you in the next video.